Hey kids, welcome to 1.6, Casting and Ranges of Variables, Main Solution. This lesson really focuses on typecasting, which is used to convert variables from one type to another. By casting, we don't mean something to do with fishing, but it is a very similar idea to casting a pot in clay. In Java, when you cast, you are changing the shape or type of the variable. What are we really talking about here? Well, this is a nice little explanation here in this paragraph. The casting operators int and double are used right next to a number or variable to create a temporary value converted to a different data type. For example, double 1 divided 3 would give a result instead of a int 1. Run the code below to find out how Java handles division and what casting can do to the results. Notice what happens when you divide by an int or by an int by a double, or an int casted to a double divided by an int. Oh my. Over here, what we're really going to try to do is just see what happens when we divide by either an int or a double to see what happens. I'm going to make some predictions first here. Let's take a look at our code first. The first part here is our class. Down here is our method. In the curly brackets is our method. We have 4 system printouts. The first one is 1 divided by 3. The second one is 1.0 divided by 3. 1 divided by 3.0. And then we have a double 1 divided by 3. I think the first one, 1 divided by 3, is going to give 0.33333333333. But since we can't give a decimal number here, I think it is just going to be 0. We have the same thing here, but now we have a double in it. And I think if we have a double and an int, it's always going to default to the double. So I'm going to try and see if that is it. Should be 0.33 because it's the same one as above. We have the same one here, just a number shifted around. I don't think it matters where the double is or the 0.0, just that it's there. So I think that one's going to end up in 0.33. And this one is 1 divided by 3, but it has a double. So it honestly should be just as the same up there, 0.33. Let's see if I'm right, kids. If you see down here, we got 0.33, 0.33, 0.33. It doesn't look like I divided it out enough, but you understand the premise there. Anything that looks like it has a double, even if it's divided by an integer, looks like it defaults to the double. Let's see if I'm right, kids. Java assumes that you are doing division with integers, that you want an integer result, and it will truncate and throw away the part of the decimal point. But if you use a mixture of integers and decimal numbers, Java will assume you want the double result. That's what I hypothesized above, and it looks like I'm right, kids. If there is at least one double in the operation, Java will widen the type of the operand to double 2 and return the results in a double. If you have an integer and you want to double the result for some mathematical operation, cast one of the integers to a double using double as shown above. That one is just talking about this one right here. And it's just saying if you have 2 numbers but you want it to be a double, make sure you put double in there. Values of type double can be rounded to the nearest integer by adding or subtracting 0.5 and casting with int using formulas like the following. Looks like we have int nearest int equals the integer and then the number plus 0.5. Looks like we're adding the 0.5 to round to it. That is pretty interesting. For example, if you divide 5 divided by 3 using integer division, Java will truncate 1.67 to 1 to give an int result. However, we usually round up any answer to 0.5 and above using the formula. If we add 1.67 plus 0.50, we get 2.17. And then casting it into an int throws away what's after the decimal point, just leaving 2. This This sounds like a pretty neat way to round, kids. We have a little problem down here. It says run the code below to see how the formula of adding or subtracting 0.5 and then casting with int rounds to a positive or negative double to the closest int. Before we run the code, let's take a look at what we got. We have our public class right here, our main method between the curly brackets. The first one is a double number, 5 divided by 3. The next is an int nearest, and that's taking int, an integer, and then the number variable here and adding 0.5. Then, looks like we are printing out 5.0 divided by 3 equal plus number. So this variable number right here. Then we have another system printout. Then we have another system printout. 5 divided by 3 truncated is the string, the integer number. So it's going to take this number and turn it into an integer. We have another system printout that says 5.0 divided by 3 rounded to the nearest int is plus nearest int. So this one right here should print out the final answer right there. A double negative number equal negative number, so that should give me a negative number. Then we're going to repeat here. The nearest integer is the negative number minus 0.5 since we are subtracting, since it's a negative. And then we are printing it out with the nearest integer variable that we created here, which is just basically the integer, and it's a number plus 0.5. Let's go ahead and save and run this. Let's take a look at how we got these numbers here. We are starting off with a double in the variable number, which is 5 divided by 3. 5 divided by 3 is going to be 1.66666666667. What we're going to do is we are going to make a number. We're going to make another variable here, nearest int. And nearest int is whatever this number is plus 0.5. And that's going to give us our nearest integer. Now we have our system printouts. So the first thing I'm going to do here is 5.0 divided by 3, which is going to give us 1.6666667 plus number. So this is just printing out right here, this part right here. This system printout is just saying 5 divided by 3 is 1.6666667, but we want to take that into an integer number. So that is truncated to 1. Our next line right here is our variable nearest int. So it's taking 5 divided by 3, and that is 1.66667, but it's adding 0.5. So that's somewhere around 2.1666667. And then we are going to turn that into an int because that is an integer, and that's going to round it down to 2. So on that one, our nearest integer is 2. We are doing a negative number now. So this one is a new variable, nearest negative integer, and that is a integer with the variable negative number minus 0.5. So it's basically the same thing up here, except for instead of plus, we are subtracting. And this printout basically does the same thing. Negative 5 divided by 3 is negative 1.6666667. And what we're going to do is the negative integer. So that is taking that and subtracting. So negative 1.6667 minus 0.5 is negative 2.1666667. But it's an int, so we're rounding it down. So we get the number negative 2. And that's how we figure out our rounding of our numbers. Pretty fun, kids. If you saw above, I kept going 0.6666666, and that's a common problem. So what happens if you have repeating decimal numbers like 3.33333333? Java limits the number of digits you can save for any double number to about 14 or 15. You should be aware that the accuracy of any calculation on a computer is limited by the fact that a computer can only hold a limited number of digits. For example, int values are stored in 4 bytes of memory. 4 bytes, that sounds like AP CSP, kids. There is an integer max value defined as 21474836647, I think. And an integer min value, which is defined as negative 21474836648. If you try to store any number larger or smaller than these numbers in an int variable, it will result in an integer overflow where the incorrect value could be stored. So let's try it below. So we basically have to go up or below this. So let's go and hit save and run. And you can see we have an error. Let's just try and take this to a 1, and let's see what happens. Well, that's pretty good. Let's try a 4 over there, well over our number. And we get errors again. This one's just teaching us that there's a maximum value we can hold. So if you're creating some game with lots of points, be aware of that we could create our own errors just by having our own custom scores. Pretty good to know, kids. Although it's not on the AP exam, you can format long decimal numbers to show just 2 digits after the decimal point with the following code. And the following code is really this part right here. %.02f. The 02 is the number of digits we want to do after the decimal point. So let's go ahead and hit save and run here. And you can see we got 10 divided by 3. We want to outprint the number, and then we want a format here. Let's just try to take this up to 4 and see what happens. See, I have 4 digits there. How about 6 digits? Let's play around, kids. Does this F have anything to do with anything? It does, and we're going to come to that in a bit. It's actually going to tell us some different things we can do. But for right now, let's just play with the F. So the number of digits that we want after a decimal point is related to this part of the code. We have some true or false here, kids. 165, true or false. Java rounds up automatically when you do integer division. I think that's false. True or false, casting always results in a double type. I don't think that's correct. We can cast with an integer. And 167, which of the following returns the correct average for a total that is the sum of 3 int values? So we want the sum total of 3 int values. I think that's going to be a total. Let's see if I'm right. Looks like I'm wrong. When you divide by an integer, you get an integer result and lose the fraction part. So we want the correct total for the sum of 3. I'm going to say it's going to be C then, because I think I want a double of the total of the 3. And there you go. So that's just a little tricky one, showing that we need the full total, not just the integer total. 1.6.1, a programming challenge. Average 3 numbers. Use casting to report the result as a double. For example, if the grades are 90, 194, the sum of the 3 numbers is 90 plus 100 plus 94 equals 284. And then the average is the sum 284 divided by 3, which is casted to a double, which is 94.666667. You should use your variable instead of numbers in your formulas. Follow the pseudo code below. Let's take a look at our code here. We have our class, followed by our method, which is in between the curly Q brackets, and we have some comments over here. It looks like I'm going to put something in between each of these comments here. The first thing I need to do is declare 3 int variables, grade 1, grade 2, grade 3. I think I'm just going to still their grades up here because it'll make it easy, and we can double check our numbers as we go back and forth. Let's go ahead and make up these values. First one's going to be an int, and we're just going to call this grade 1. And grade 1 is going to be equal to a 90 in our semicolon. Int 2 is going to be grade 2. You can name this whatever you want, midterms, finals, whatever you would like. I'm just using these as placeholders. Second one is 100. Don't forget your semicolon. And our third is grade 3, which is also going to be, not also, it's going to be 94. That takes care of this part up here. So let me just delete this out here. This part takes care of there. Let's look at our second part. This one says declare an int variable called sum for the sum of the grades. Well, that just makes basically making an int. Let's get this lined up right, kids. And we're going to call that sum, and we're just going to set that equal to 0 right now. The next one here says declare a variable called average for the average of the grades. And if you remember, we want to get the actual number here, right? We want the 66667 part, so we need a double. So this one needs to be a double as well. That is going to be double. We're going to call this average, and that is going to be equal to 0.0. Spell that right again. That's just taking care of our average there. And again, we are using double because we want it to be a precise calculation. Next, we're going to write a formula to calculate the sum of the 3 grades and add them up. I bet you that's just going to be an addition one. I think I'm just going to do sum equals, and I think it's just going to be grade 1 plus grade 2 plus grade 3. So sum equal grade 1 plus grade 2 plus grade 3. Don't forget your semicolon. I'm just cleaning this up again. The third or fifth one down here, write a formula to calculate the average of the 3 grades from the sum using division and typecasting. Woo! That sounds hard. Well, it's not too bad. We already have an average up here, so we're going to use that one. It's already declared as a double, so I don't think I need to do anything else. But I know I'm using some integers here for my sum, but we'll get to that in a second. My sum is really just sum divided by 3. Because we want to calculate the 3 averages, you divide that by 3. But again, I want this to be a decimal point or a double, so I am going to put the modifier double in front of there. That should give me the sum divided by 3 is my 0.666667. Let's clean this one up. And now we got to print it out. And what are we going to print out? Well, we're going to do a system.out.print. Do we need an ln on here? No, I don't think we do, but let's just throw one on for the fun of it. We're going to say our score, we got to put in quotation marks because our string is words. Your average is space, quotation marks, plus what variable we're trying to get? Average. We need to close that, then put a little colon there. Make sure it is spelled right. It looks like everything is right. I have my curly cues closing up my code. Let's go ahead and save and run this. Uh-oh. Looks like I have an error. And the error looks like I just forgot a semicolon. Classic roads. Let's run it again. There you go. Looks like the code prints out perfect. How we go through and average grades in code. We could also do this in repl.it if we wanted to. All right, kids, let's go ahead and code this into our repl.it here. We're pretty much going to remake the same program as before. So we're going to do an int, and we need 3 variables. And this is going to be like my one before, grade 1, which is going to be equal to 90. We have another int, grade 2, which is going to be equal to 100. And our final int is grade 3, and that is going to be equal to 94. Next, we're going to come down here, and we are going to get we're going to declare a integer variable called sum, and the sum is going to be for all of the grades. So we're basically just going to make an int sum, set that equal to 0. Make sure you got your semicolons there, kids. As before, we need to make this into a double because our average should be a point number. We want it as precise as possible. How do we get that? Well, we write double to begin with. And our average is going to be equal to 0.0. Next, we need to write the formula, which is going to add this all up. And what's that going to be? Well, that's our sum. And our sum is equal to grade 1 plus grade 2. Look at these come up for us, kids. Plus grade 3. Semicolon. So my sum should be grade 1 plus grade 2 plus grade 3. Now we have to write the formula for calculating the average of the 3 grades. Remember, to calculate the average, we basically take the sum, divide it by 3. But kids, we want it to be in decimal. So we're going to do our average is going to be equal to what? Well, we want the double number here because we want it to be precise, a decimal point, and just the sum divided by 3. That should give us that. And then finally, we have to print out our fun little mess here. So system.out.println, and we want your average for this class is, and then we want to string this together. So string, and then we just get the average. After that, you hit your little semicolon. Well, that should be everything. Let's give it a run and see if we coded this in right. Your average for the class is 94.66667. That's just how we pull our code into repl.it and write it out. All right, try the following program which prints out Chinese characters. Look up the other characters at this Unicode. So we have a whole site here with different codes in order to get the letter. So a little tilde here would be whatever this is. The Greek capital letter, this would be these numbers here. So this is how we actually get that stuff there. If we come down here and look at our code, we have our class, we have our method, and let's take a look at our printing here. So A is an ASCII, if you don't remember that's ASCII. That's all those fun little word pictures you see on the internet and memes. And the Unicode is the decimal number 65, and we have character 65. So let's look up what the decimal is over here. These are hard for me to see, kids. What looks like a period? Oh, that looks like it here. So the Unicode should be this part over here. Let's try it out. Before we get too much into this, let's go ahead and save and run and see what happens here. If you look, we got a fail true thing here. It looks like we have to edit some code. So let's go ahead and try it out. Let's do the first thing here. Let's do a different character of 65. Let's see what another language is. So if we come down here, it looks like this right here should be the code for the part right here. So instead of 65, oh, the decimal number, we got to look for the decimal number. I'm sorry, kids. We're going to look for 903. So let's try 903. Let's hit save and run. There you go. The code is changed. So we did the decimal of the other one there. Let's see the next one. It says we have a printout. Can you typecast a decimal number for the character, for the Chinese character for sun? This one is asking if we can do a typecast for a decimal number. If we go to the Chinese character for sun, which is character 11932, let's see if we can do 11932 is the character for the sun here. Now let's see what we're asking here. Can you typecast a decimal number for a character? So we want to know if this can be a double. So on here, let's just point 0.00. Let's see what happens. And you can see it looks like it is printing out fine. So we can use those decimal numbers in our code. The final one, we're going to look at the Unicode. So, or can you print out the Chinese character for moon using Unicode? And this is the hex number given right there. So let's look at the Unicode number. So we need to print out the Chinese character for moon right here using Unicode. I'm going to copy and paste that in. I'm going to come over here and paste that in. And let's see what we get. Let's hit save and run. And there you go. We have the number 65 still. We have the Chinese character for sun. And we print out the Unicode for moon. So that's just a fun little way to change things around. This just one's just having you look up again through your Unicodes and just seeing how we can represent information differently. That's it, kids. We have some vocabulary at the end, but that is all of the activities. Hopefully you found this video on casting helpful.